Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this session on instrumental methods of analysis. Today, in this video, we are going to discuss about the instrumentation of infrared spectroscopy. Previously, we have covered with the different molecular vibrations that are associated in the infrared spectroscopy. We have seen basically there are two different types of molecular vibrations. One is the stretching and bending. Further, these stretching vibrations and bending vibrations are also classified into different types. So if you have not watched my previous video, you can watch my previous videos related to the infrared spectroscopy as well as the instrumental methods of analysis. And if you like the content of this my YouTube channel, please subscribe to my YouTube channel, like my videos and share with your friends. So let's begin with our today's session. Before starting with our today's session, first we will see what are the learning outcomes of this session. After this session, students will be able to explain the instrumentation of IR spectroscopy. Basically, when we are going to study the instrumentation of infrared spectroscopy, the important aspects related to infrared spectroscopy, there are majorly four components that are involved in the infrared spectroscopy. These main four components of IR spectrophotometer, these are IR radiation source, that is the radiation source that is used to produce the infrared radiation. These radiations are absorbed by our sample. Then second important component that is used in the IR spectrophotometer is monochromator. Monochromator is, as we know, that is used to convert the light into its individual component, that is the polychromatic light into the monochromatic light. Then third important component of IR spectrophotometer is sample cell and sample handling system, that is the sampling of substances. One of the beautiful thing about the using IR spectrophotometer is we can use sample in any form, that is in liquid form, in gaseous form, as well as in the solid form. Like in UV, we have seen that if we want to use the UV spectrophotometer, we have to use sample in the solution form only. Solid or liquid, solid or gaseous form of sample we can't use. But in IR, that is the IR spectrophotometer, we can use the solid sample, liquid sample, as well as the gaseous sample. So for that purpose, different cells and sampling techniques are utilized for handling different types of the sample. And the last important, that is the fourth important component of IR spectrophotometer, is detectors. So these are the four important components or parts of IR spectrophotometer are there. In detail, we are going to discuss these particular components individually also. But just you can remember these four components so that when I will explain the instrumentation part, that is the how instrument of infrared spectrophotometer or spectroscopy works, so that you can understand how these components are useful and what is the role of these components. So let's begin with the working of the instrument of the infrared spectroscopy. Basically, as I told you, the first important component is a radiation source. The use of radiation source, that it produces the radiations in the IR region. As we know, infrared region is the most wide region, which is also divided into three its subcomponents: mid, far, and the near infrared region. So basically, the whatever the working instruments are there, they mainly working in the middle IR region, that is the middle infrared region. Also, we know that the range of infrared radiation is starting from 0.8 micrometer to the 2.5 micrometer. So this is the wide range of infrared radiations are present. So role of this radiation source is to produce the IR radiations which are focused onto the sample. Now there are various source or lamps are used as a IR radiation source. First important lamp that is used as a IR source is incandescent lamp, then nurse glower, third one is the glober source, and fourth one is the mercury arc. So these are the four important radiation sources that are used in the IR spectroscopy. Here I will be only discussing the four other other radiation source are also utilized, but here I am not going to discuss this. Just for instance, you can remember these are the four different main radiation source that are used. In detail we will discuss in a later video, but here just only you can remember that four different radiation source are used in the IR spectroscopy. Then the radiations that are produced from this radiation source, they will be focused on the reflecting mirrors. Now there are two different types of mirrors are generally used, flat mirrors as well as the concave mirrors. Here these flat mirrors are generally used. So when the light falls on these mirrors, it will be reflected and it will be directed to the second type of the mirrors, which are known as the concave mirrors. From these concave mirrors, means whatever the light is there, it will be split into two parts. One will go towards the reference and other one go towards the sample. So these both the lights now focused on the reference cell as well as the sample cell. Here this type of working is known as the double beam IR spectrophotometer. Why double beam? Because the whatever the single wavelength light that is coming out from the radiation source, it will be measured at a particular time, that is the reference as well as the sample. The difference between the reference beam and sample beam is measured at a single wavelength. Here the whatever this light, that is the light that is passing through the sample, when it goes or it will strike on the surface of the sample molecules, it will the light that is absorbed by the sample and some amount is transmitted as such. As we know, IR spectrophotometer measures the transmittance. Some amount of light is absorbed and some amount of light will be transmitted. But here, as there is an absence of sample, due to which all the light that is coming out from the radiation source, it will be transmitted. So 100% transmitter is observed if the cells are not absorbing the IR radiation. So it will carry out the differentiation between the reference beam as well as the sample beam. Further, the light that is coming out from the reference beam as well as the sample will fall again on the concave mirrors. From that it will be reflected towards the chopper. Now why this chopper is placed? This chopper is continuously rotating about 10 rotations per second generally. So what is the role of this chopper? Due to the rotation of this chopper, alternatively reference beam as well as sample beam will fall on the detector. So detector will measure the reference beam as 100% and it will count the light that is transmitted. Say for example, sample will absorb 60% of the light, then only 40% of light will go towards the detector. In this way, it can subtract from the reference and the sample and it will calculate and it will measure the transmittance. In this way, alternatively, the light from the sample and the reference will go towards the detector. Before going towards the detector, a monochromator system is utilized. We know what is the role of monochromator. As I said, this is the another most important component of this particular IR spectrophotometer. Role of these monochromators is to carry out the separation of light into its individual component. There are two different types of monochromators that are used, prisms and other one is the gratings. Prisms are not that much sensitive. So generally whatever the modern instruments are there, they utilize the grating as a monochromator. Further, this grating, that is the monochromator, is continuously rotated. So whatever the light that is falling on the surface of this monochromator, it will be converted into its individual component and single light is allowed to pass through the slits. Generally different slits are placed before the monochromators as well as after the monochromators. Then this light that is coming out from the gratings that will go towards the detector where they are measured. Now there are different types of detectors that are used. Just I will quote the names of these detectors. One is the bolometer, then second one is thermocouples, thermistors, pyroelectric detectors, and Gole cells. So these are the important detectors. Few other detectors are also there, but just I will discuss only these 5 detectors in the instrumentation of IR. These detectors we will discuss in detail in the latter part of the video. So here in this way the working of the infrared spectrophotometer or the working of IR spectroscopy is carried out. So this is about the working of IR spectrophotometer. Now first we will discuss the first component of this IR spectrophotometer, that is the IR radiation source. Infrared instruments need a source of radiant energy which provides a narrow frequency band, the radiations that are present in the narrow frequency band. The radiation source must emit only IR radiation, which should be intense enough for the detection. Then they must be steady and they extend over the desired wavelength. So these are the various characteristics of the IR radiation source. Whatever the radiations that are emitted should intense, they must be steady, and they extend over the desired wavelength. So these are the various characteristics that IR radiation source possesses. As we know that there are 4 different radiation sources that we are going to discuss. The various popular source of radiation source are as follows, as I told you in the working part: incandescent lamp, nurse blower, Glober source, and mercury arc. Let's discuss one by one. First one is the incandescent lamp. Now what is the meaning of incandescent lamp? The electrical light source which works on the principle of incandescent phenomena. That's why it is known as the incandescent lamp. In other words, the lamp works due to the glowing of the filament caused by electric current passing through it. Therefore it is called as incandescent lamp. The working of this lamp is like just our tungsten lamp, where the filament is heated, and due to the supplying the energy in the form of the electrical energy, this filament gets heated, and when this filament becomes hot, the atoms inside the object become thermally excited. If the object does not melt, the outer orbit electrons of atoms jumps to higher energy level due to the supplied energy, and due to this the electrons on these higher energy levels are not stable, and they again fall back to the lower energy levels. And while coming back to the lower energy levels, the electrons, they emit the extra energy in the form of the photons. So this is the working of incandescent lamp. They are now generally not utilized because other important IR radiation sources that are used. So this is about the incandescent lamp. The photons that are emitted from the surface of the object in the form of electromagnetic radiations, and they are acting as a IR radiation source. The next radiation source that we will discuss is nurse blower. This is the important, one of the most widely used as well as the important radiation source that is used in the IR spectrophotometers. The nurse blower is a device that is used for providing a continuous source of the infrared radiation. Incandescent lamp is having problem that the radiations that are generated are not continuous, but nurse blower will supply the radiations which are continuous source of the infrared radiation. Typically it was in the form of the cylindrical rod or a tube which is composed of mixture of certain oxides such as zirconium oxide, yttrium oxide, and the erbium oxide at the ratio of 90:7:3 by the weight. So this is the typical example. So again the construction is quite same. The filament is used, but instead of making the filament of the tungsten, here these particular certain oxides are utilized, that is the zirconium, yttrium, as well as the erbium oxide. Other oxides are also used for preparation of the nurse blower. They are operated by being electrically heated to about 2000 degrees Celsius. Initially they require electric external heating because the material is in the insulator at room temperature. It has been replaced by the similar devices known as the Glober source made of silicon carbide that operates at about 1100 degrees Celsius. it is better suited for the evacuated system. Thank you.